Imagine the most extreme objects in the universe. These are not just stars or planets, but remnants of once mighty celestial bodies that have undergone cataclysmic transformations. We journey now to these bizarre remnants of dead stars, where the laws of physics are pushed to their limits and beyond. Neutron stars, tiny, dense, and unbelievably hostile. These stellar remnants are the cores left behind after a supernova explosion. They are the cosmic equivalent of a graveyard where the remains of stars lie in eternal rest, yet with a haunting presence. These are places of immense power where the energy released can outshine entire galaxies for a brief moment. Places we should be grateful are very far away, as their intense radiation and gravitational forces would be catastrophic to life as we know it. Neutron stars are fascinating objects with magnetic fields trillions of times stronger than Earth's, and the ability to spin at incredible speeds. They challenge our understanding of physics, presenting puzzles that scientists are still striving to solve. They push the limits of what we thought was possible, from their immense density to their powerful gravitational waves. In this essay, we will explore these strange objects, delving into their mysteries and uncovering the secrets of these cosmic graveyards. Neutron stars are born from the death of massive celestial bodies. The death of massive stars, much larger than our Sun, marks the beginning of a spectacular cosmic event. When these colossal stars exhaust their nuclear fuel, they can no longer support themselves against the relentless pull of gravity. The core collapses inward, leading to a dramatic and violent transformation. This inward collapse triggers a supernova explosion, a cataclysmic event that outshines entire galaxies for a brief moment. The supernova is one of the most powerful and energetic events in the universe, releasing more energy in a few seconds than our Sun will in its entire lifetime. The outer layers of the star are violently blasted into space, creating a spectacular display of stellar debris. Meanwhile, the core continues to collapse, eventually forming a neutron star, or, in some cases, a black hole, depending on the mass of the original star. The core is now incredibly dense. A teaspoonful would weigh billions of tons on Earth. The protons and electrons in the core are crushed together. They form neutrons. This is how the neutron star gets its name. Neutron stars have extreme gravity. The gravity is so strong that it warps the fabric of space-time. They also have incredibly strong magnetic fields. These fields are trillions of times stronger than Earth's. Section 4, Cosmic Arsenal, Neutron Stars as Weapons. The immense power of neutron stars is awe-inspiring. Could they be used as weapons? It's a question that sparks the imagination. Imagine harnessing the power of a neutron star. The energy output of a neutron star is colossal. Their magnetic fields are capable of unimaginable destruction. However, the practical challenges of harnessing this power are insurmountable, at least for now. Section 5. When titans clash, explosions of unfathomable power. When neutron stars collide, the result is cataclysmic. These dense remnants of massive stars, each with a mass greater than our Sun but compressed into a sphere only about 20 kilometers in diameter, unleash unimaginable energy. The energy released is greater than any other explosion in the universe, except for the Big Bang itself. This colossal burst of energy can outshine entire galaxies for a brief moment, illuminating the cosmos with a blinding light. These collisions create ripples in space-time, known as gravitational waves. These waves travel across the universe, carrying with them the echoes of these monumental events. These events are rare, occurring perhaps once every 10,000 to 100,000 years in a galaxy like ours. But when they do happen, they provide us with invaluable information about the universe. By studying these collisions, scientists can learn about the universe's most extreme environments. The data collected helps us understand the behavior of matter under conditions that cannot be replicated on Earth. We can test our understanding of fundamental physics, including the nature of gravity, the behavior of nuclear matter, and the limits of our physical theories. These objects are both fascinating and terrifying. Their immense gravitational pull and the forces they unleash are beyond human comprehension. They remind us of the vastness and power of the universe. The scale of these events is a humbling reminder of our place in the cosmos. We are fortunate that they are so far away. The energy released in these collisions could have devastating effects if they occurred closer to our solar system. For now, we can only observe these cosmic wonders from a safe distance. Telescopes and observatories around the world are constantly on the lookout for these rare events. We can marvel at their power and mystery, appreciating the incredible forces at play in the universe. These explosions of unfathomable power are a testament to the dynamic and ever-changing nature of the cosmos.